Good evening. See, in the last topic we study about the causes for attenuation. I explained you about the first one, that is nothing but an absorption loss. Second one is scattering loss. Third one is waveguide bend loss. By bending the fiber you got a loss. And fourth one I explained to you is core and claddie loss, because of some power that moves into the claddie is lost. That's what our power present in the core was going to be less, which is created as a loss. So, core clad loss. And after that we see about the next important one, that is said to be called as our dispersion, intermodal dispersion and intramodal dispersion. So, yesterday we stop up to that part. We study both the two dispersions. One dispersion is due to the modes that light travels in fiber in different types of modes. Other one is due to the light source. Because of light source contains many wavelengths, we are having the dispersion. So, these two things are very important whenever we discuss about the dispersion. So, for having a good what is called system efficiency, good efficiency, or when you have that good utilization of bandwidth and transmit more amount of bit rates also, make clear such that your attenuation must be less. To make your attenuation to be less, we definitely want our dispersion also to be less. But dispersion is less whenever you are operating at higher wavelengths. Hope you understand that point also. Whenever we are operating at a very high wavelengths, we can find out clearly such that dispersion is becoming less. So, I told in the class lambda increases in the sense means V will decrease. So, lambda increase, V decrease by a. See, one hand lambda increase, other hand V decrease. When V decreases, similarly what happened is definitely your delta decreases. Your delta is going to be decreases, number of modes will be less. Number of modes will be less, delta T will be less. Delta T is less means dispersion is less. If dispersion is less, क्या हो जाएंगे means very simple thing, the system performance will increase. So, that's why what you are talking about in the classroom is we want to make our attenuation to be less. We are trying to studying that only for the complete day. Yesterday also we focus on the complete class for attenuation to be less. And today's class we will see about the remaining parts of the attenuation and end the session with the help of the numericals. So, get a good clarity that why you are studying the complete remaining part also. So, I request all the students, so pay the same attention like for your previous classes how you studied in the same manner. So, I am going to starting the class with no more delay, right. So, please see here bhaiya coupling loss bhaiya. So, when you discuss about the coupling loss, so if you see the coupling losses, coupling loss is obtained due to the optical components. It is coupling loss obtained due to optical components. So, due to the optical components we are having the coupling loss. So, due to the optical components. Bhaiya, what are the optical components we study in the classroom? I told in the class such that we are having 4 types of optical components are present bhaiya. Pehla wala hai connector, dusra wala splice, तीसरा वाला it is our coupler, and char, fourth one is it is repeater. Okay. Now, just see here bhaiya, पहले वाला है हमारा connector, component is connector. So, दूसरा वाला is nothing but an, it is called as your splice. Third one is we can call it as your coupler, it is called as coupler we are having. Okay. So, fourth one is it is said to be called as the repeater we are having. It is called as the repeater we are having. So, this is completely what said to be called as the coupling loss we are having, and this coupling loss is obtained due to the optical components. The name itself indicates suggesting something to us. What is suggesting something? That is coupling. Whenever you are coupling means when you are fixing. When you are fixing something, your loss was getting. That is called as coupling loss we are having. So, if you see that a connector is used to couple your light from light source into a fiber. Whenever it is coupling light from light source into fiber, we have some loss, and that loss is called as connector loss. Loss offered by the connector. Okay. And that connector loss we are having is due to also called coupling losses. Okay. Also called as coupling losses. So, everybody in the class understood this. So when you talk about a coupling losses, so first important thing, it is obtained due to optical components. So coupling loss, your coupling loss is of two types. So coupling loss is of two types, whatever the coupling loss we are having. So coupling loss is of two types we are having. The first coupling loss is called as our misalignment loss. It is called as misalignment loss, first coupling loss. And second coupling loss is called as mismatch loss we are having. It is called as mismatch loss we are having. So one is called as misalignment loss, other one is called as mismatch loss is present, which is called as coupling loss. So coupling loss is of two types, misalignment loss and mismatch loss. So now what we are trying to doing is, we are talking about the misalignment loss. I am writing the misalignment loss, and such misalignment loss is of three types we are having. So three types of misalignment losses are present. So first misalignment loss is called as first misalignment loss is called as lateral misalignment. It is called as lateral misalignment. Second misalignment loss is called as gap misalignment. Third misalignment loss we are having is called as angular misalignment. So this is nothing but three types of misalignments we are having. First one is called as lateral misalignment, second one is called as gap misalignment, and third one is called as angular misalignment we are having. So now we can see about the remaining things about in detail. Please concentrate. So just see here, भैया ये हमारा फाइबर है, हमारा ट्रांसमिशन फाइबर है. So hope you understand this fiber, which is called as transmission fiber we are having. So this is the transmission fiber, this is core and this is claddy. This fiber is represented as transmission fiber we are having, and this is called as the axis of the fiber. It's called axis of the fiber. And whenever we are discussing about this fiber, it is said to be called as your said to be called as the another fiber, which is called as receiving fiber bhaiya. It is called as receiving fiber we are having. Both are not on the same axis, they are not lateral, they are not on the same axis, and this difference between them is called as L. The difference is equal to L. See, I am writing here the difference what is present between them is called L. L stands for the lateral. They are not aligned to each other on the same axis, they are not present on the same axis, and such is going to be creates a loss called as alignment loss. Just observe carefully, because of this they are not on the same axis. What happened is the power is going to be losted from here, it cannot be hitted to the fiber. So whenever you are combining the two fibers by using splice or by using connector, two fibers are connecting to each other, we can definitely have a loss. Such loss is called as your misalignment loss, which is called lateral misalignment. So make sure such that they both will present on the same axis, on the same line of the axis. If they are not on the same line of the axis, then definitely we are facing a problem called as loss occurs, which is called as your lateral misalignment loss. Please concentrate bhaiya, I am doing with another color pen to get a clarity. It is a transmission fiber. See, transmission fiber it is, and it is called as receiving fiber also. So transmission fiber and receiving fiber we are having. So this is what said to be called, and they are present on the same axis. What is called on the same axis we are having. It is called, they are present on the same axis. Now the axis is same bhaiya, the axis is same, and which is going to be shown like this. The axis is same, there is no lateral misalignment, but we have some gap is present in between them. So please concentrate, these are the two fibers I am placing to each other like this. I will show it with another one also. भैया देखो भैया, ये टू फाइबर्स भैया, आई होप इट इज़ विजिबल टू यू, थोड़ा आगे आएंगे. देखो ये टू फाइबर्स है, ये टू फाइबर्स का इसी तक सेम एक्सिस में है, और इसका सेम एक्सिस में भी है बट थोड़ा गैप है, इसका बीच में थोड़ा थोड़ा गैप है, एक गैप के लिए हम फिल करेंगे, स्प्लाइसिंग से फिल करेंगे। ओके, सो ऑप्टिकल जेल और ऑप्टिकल सीमेंट थोड़ा स्प्लाइसिंग से फिल करेंगे। सो इधर स्प्लाइसिंग का फिल करेंगे और फिल किया। सो इधर भी है ना, ग्लास मटेरियल से फिल किया। सो देखो भैया फिल हो गया। सो व्हाट वी आर सीइंग फ्रॉम द आउटसाइड, वी थिंक दैट इट इज फिल्ड कंप्लीटली, बट इंटरनली वी हैव सम गैप, दैट इज कॉल्ड एयर गैप. So you done the splicing but not done in an effective way. Outside, from outside it seems to be that splicing is done perfectly only, but it's not done perfectly. It is having some gap internally present. Now what happened with that gap, I will explain to you. Just check it carefully bhaiya. So two things will happen. Case 1, I am explaining with case 1. Whenever the light will come and incident will get reflected, hit the surface, it will be returned back, and that loss is said to be called as the which loss? Return loss we are having. That is called as the return loss we are having. So whatever we are having, that will going to be returned back because of that air gap. Why it is returning back? Because total internal reflection is taking place. The light is moving from denser to rarer, because air will have a refractive index N naught is 1. And the light is moving from denser to which one? Rarer. When it is moving from denser to rarer, it may have, because of hitting that, it may have total internal reflection will be takes place. Okay, and move back to the same medium, which is called return loss. Or case 2, the is not reflected, it may refracted, but refracted also some power will be get losted. Either it reflected, losted, either it reflected, also losted, because the gap is going to be creating a problem. Why? For example, there is no gap bhaiya, then light will pass directly, because both the two mediums are same. We study in the classroom, whenever the two mediums are same, you know very clearly such that the light will travels with the same angle of incidence, refraction angle and incidence angle are same. N1 is equal to N2, which is called as case 1, explained to you in the review of optics. Now you understand clearly such that it is having the gap misalignment will create a loss called as return loss. Return loss is created by the your gap misalignment. Next one is angular misalignment bhaiya. When you talk about the angular misalignment, you are going to be having the so called shape looks like this. It's called as the angular misalignment. Called as angular misalignment. Some gap is present, and that gap is said to be called as theta. That gap is said to be called as theta, which is called as angular misalignment we are having. This angular misalignment will creating a problem called as light will be get deflected. So these three are the misalignments. Because of this misalignments, we have loss of information or loss of the light rays, which is not supposed to be occurs, and this coupling losses is completely man-made losses. Man-made mistakes bhaiya. These are man-made losses. The technician must be aware of these losses, and he has to avoid these problems, such as whether splicing is done perfectly or not. They are on the same axis, lateral misalignment will be avoided. There is no gap angular has to be present when you are doing the splicing. So he must be very much careful while doing the splicing techniques. Okay, and making the coupling of light source to the fiber or fiber to fiber coupling will be done effectively. Please copy it bhaiya. I will explain the next one called as mismatch losses. You please copy this part, all of you. Good evening Radhika Devi, good evening Komal, good evening Sajal Jain, good evening Somya, good evening Sagar, good evening Keshav, very good evening. Please copy it Nana. I will explain you the mismatch losses. See, in angular misalignment, what happens is between the transmission fiber, this is transmission fiber, and receiving fiber, they are not placed with the same angle as a flat, not maintaining 90 degrees like this. They are not maintaining that to put the transmission and receiving fiber in the same without having any angle, not like that perfect vertical position is not placing. Therefore, having some angle, because of some angle some bending is there, because of that some angle is formed and they done the splicing as it is like that. So, for that what happened is we are going to be creating a problem, and the problem is called as loss will occurs because the light will try to escape from this one instead of moving into the fiber. So, this is called as angular misalignment. So, gap misalignment, what the gap misalignment means? Splicing is done here, see splicing is done here, but the problem is after doing the splicing some air gap is present inside the between the two fibers, and that air gap is completely making us for getting the reflection of the light which is called as return loss, getting reflection into the same medium, not allowing to pass into another fiber, reflecting into the same medium, which is called as return loss we are having. So, after this we can see about the next one. Bhaiya thoda focus karo. I am talking about the mismatch losses. So, dear students, concentrate on the mismatch losses. Very simple, you will understand the concept very easily. Mismatch losses. So, when you talk about the mismatch losses, the first point I want to tell to you here is area mismatch. We will talk about the area mismatch. So, when we find out the area mismatch, this is the fiber which is called as transmission fiber. The area of the transmission fiber is equal to A1. This is called as the receiving fiber. It is receiving fiber. The area of the receiving fiber is equal to A2. Observe carefully one point. Transmission fiber hai na, the area A1 is greater than A2. A1 is greater than A2. Loss is high. Loss is high. Whenever the area of your transmission fiber is greater when compared to area of your receiving fiber, then definitely the loss is very, very high. So, whenever you are making a coupling of two fibers, make sure such that their areas must be same. I want to explain the second case. Just try to understand the second case we are having. Okay, that is case 2. So, whenever we are discussing about the case 2, the area of the transmission fiber is less. The area of the transmission fiber is less, and the area of the receiving fiber is very, very high. Area of the receiving fiber is very, very high. This is your receiving fiber. Your receiving fiber area is going to be equal to A2. Your transmission fiber, if you talk about the transmission fiber, your transmission fiber area is equal to A1. Transmission fiber area is equal to A1 we are having. So, once we talk about this value, we can tell very clearly such that the transmission fiber area is equal to A1 we are having. So, what we are trying to doing is the condition I am written here, your A1 is definitely going to be less than A2. When A1 is less than A2, then what happened is there is no loss is present. There is no loss. So, when A1 is greater than, when A1 is less than A2, there is no loss, but when A1 is greater than A2, loss is very, very high. The loss what we are having is very, very high whenever we are talking about the A1 is greater than A2, but loss, there is no loss when A1 is less than A2. So, I want to explain a small concept here to make it clear about this one. Just observe here all of you. देखो भैया, try to understand, everybody in the class. Whenever we are writing about this fiber, the loss is going to be high, and A1 and A2, so no loss, transmission fiber and receiving fiber. This is a big tube where the water was coming from the big tube, small tube. Imagine for 2 minutes of time. ये बड़ा ट्यूब है, इसका अंदर से ज़्यादा फोर्स से वाटर आ गया, हमको स्मॉल ट्यूब उसमें निकाल दिया. ओके, वी जस्ट पुट ए स्मॉल ट्यूब इनटू दैट वन. क्या हो जाएंगे? पानी बाहर आ जाएंगे. ऐसा और नो? वाई? बड़ा ट्यूब है ना, सो स्मॉल वॉल्यूम ऑफ वाटर इज गोइंग टू पास इनटू स्मॉल ट्यूब एंड रिमेनिंग वाटर विल वेस्टेड. ना देखो भैया, ए स्मॉल ट्यूब है, ओके, कितना फोर्स से वाटर आ गया केस टू में, ये बड़ा ट्यूब में निकाल दिया. Now water will go in the forward direction only, it may not become outside, therefore the loss is not present. Very simple. So A1 is greater than A2, we have definitely a loss, but A1 is less than A2, we are not having any loss, and that is what the area mismatch. But make sure such that even though when A1 is less than A2 also, don't make sure such that two fibers will be fabricated. Make the areas will be match. What is the mismatch? Here the mismatching is done with respect to area. For example, A1 is equal to A2, both are same, no mismatch, means there is no area mismatch. Followed na? Simple na, very simple. Now see here, so second one I am explaining to you, that is called as your second loss, bhaiya, that is nothing but second mismatch loss, that is called as your numerical aperture mismatch. Dear students, please focus for 2 minutes of time. So here the area of the two fibers is same, very good, the area of two fibers is same, and the transmission fiber and receiving fiber areas are same, but numerical aperture is different. Okay, ये क्या है? This one is called as transmission fiber है, and ये क्या है? This one is called as the receiving fiber है. So transmission fiber and receiving fiber, two fibers are present. Now what we are trying to doing here is the numerical aperture mismatch. What is the formula for numerical aperture we study in the classroom? Na is equal to, come on guys, tell the formula, n1 square minus n2 square. Very good, Nana. So the refractive index of core is n1, the refractive index of clady is n2. So core refractive index is n1 and clady refractive index is n2. So n1 and n2 is present under the root of n1 square minus n2 square is the value we are having. So this is called as Na. Talking about the receiving fiber. When talk about receiving fiber, it is called as n1 dash, it is called as n1 double dash we are having. So the refractive index of the two fibers are not same. Means what happened? The numerical aperture of the two fibers may not be same. Yes or no? Very good. Good catch, bhaiya. Now Na dash is equal to under the root of n1 dash square, n1 dash, this one n1 double dash I wrote it, please make it change bhaiya, not n1 double dash, that is n2 dash, okay, this is n2 dash we are having, it's n2 dash, right, dekho idhar, it is n2 dash we are having, that is n2 dash. So I am writing here also, that is called as n2 dash we are having, okay. So this part was said to be called as n2 dash whole square is present. Hope everybody in the class, now your Na is not equal to Na dash, now Na numerical aperture is not equal to Na dash. When Na is not equal to Na dash, the two fibers are having different numerical apertures, then we are definitely going to be having the mismatch, which is called as numerical aperture mismatch. ठीक है भैया? हाँ, next one. So now talking about the third mismatch. देखो भैया, third mismatch है. Whenever we talk about the third mismatch, we can tell like this. Thus, that mismatch is said to be called as the profile mismatch. I request all the students, please concentrate on the last mismatch. Then I can explain you the components, bhaiya. All the optical components I will explain to you. So profile mismatch. So name itself indicates there is a change in the profile, bhaiya. So dekho bhaiya, this is our transmission fiber. I hope everybody in the class understood this. It is called transmission fiber. and this fiber is called as receiving fiber. So I hope you also got this concept. It's called as receiving fiber and transmission fiber we are having. Now what I am doing is I am writing about the your profile. See, this is the profile we are having. Okay, this is the profile we are having. So just observe this. This is the profile we are having. The profile looks like a step profile. It is called as the step profile we are having. It is called as step profile we have. Okay, but whenever we are discussing about this one, it is called as the parabolic profile. It having a parabolic profile. The two profiles are not going to be same. Okay, so they are called as parabolic profile we are having. Okay, so it's called as parabolic profile. Right, see here, parabolic profile we are having. It is called as parabolic profile is present. So this is what said to be called as the profile mismatch. So whenever you are mixing two fibers, make sure such that don't mix of two different profiles. Make sure such that the profiles must also be same. Fibers seeing from the outside, they seems to be having the same only. What they seems to be having the same area only. But the thing is, we need to know about that which profile they are having. So for step index fiber and grade index fiber, we cannot mix both the two things. They are two different one. Okay, which is called as our mismatch losses. I hope everybody in the class understood about these losses. Okay, Bhaiya. So please copy this part. Once copying is completed, put a message also. Sagar, we cannot call the angular misalignment as gap misalignment. In gap misalignment, we don't have any angle. In angular misalignment, we have some angle is present, Nana. Okay, some angle is present. Yeah, complete copying. Next one. So I am explaining you about the next concept, that is called as optical components. So by optical components in the link which are called as optical devices also. Optical components or optical devices we are having. optical components or optical devices we are having. So, when you talk about the optical components or optical devices, the first important point that we can see here is nothing but an connector. The connector is also called as source to fiber coupler. Source to fiber coupler we are having. It is called as connector, connector is called as source to fiber coupler. The first one is, we can tell about this, it is called as it is a mechanical device. Connector is a mechanical device. Connector always performs a temporary connection. Temporary connection between first one is, it is called as light source to fiber. Temporary connection between light source to fiber. Fiber to fiber. Fiber to fiber. Fiber to photodetector. Fiber to photodetector. So, this is what said to be called as the connector we are having. Such connector is going to be makes a temporary connection between your light source to fiber, fiber to fiber, or from fiber to photodetector also. Already explained in the starting of the class only, I show it to you where the connectors are going to be uses. Okay. At that instant you will also find out very clearly. So, those are called as your temporary connections are formed between light source to fiber, fiber to fiber, and fiber to photodetector we are having. So, next important point when you see about the connector, the third important point, that is called as types of connectors. When you are going to be seeing about the types of connector bhaiya, so we are talking about the types of connector, that is we are having three types of connectors are present. So, this is called as three types of connectors we are having. The first connector is called as screw on connector. It is called as screw on connector we are having. The second connector is called as, it is nothing but an bayonet connector. Okay, I will just explain after writing this the names I will explain to you, bayonet connector. Okay, and the third important one connector is called as the push pull configuration. It is called as push pull configuration connector or push pull connector also. Simply calling it as push pull connector, or sometimes we will call it as the push pull configuration also. Okay, bhaiya please see here talking about the screw on connector. Screw on connector I will explain to you. Try to understand this concept. Here have a screw at end of the fiber, and for that screw we are going to having a thread is present for the light source. The thread is on the light source and the screw is present on the fiber. Now, the fiber is placed on that into the light source, and you can going to be tighten this screw. When you tighten this screw, then what happens is it is going to be form a temporary connection between those two. If you want to remove that one, that means if you want to deassemble that, okay, then what you are doing is you just loosen the screw and remove the fiber. The light source and the fiber will get separate to each other bhaiya. That is called as screw on. If anybody has done in the laboratory in your final year of your BTech, you have a optical communication lab. In that lab we can see that optical fiber cable nana, which is having screw on. Screw on it is called, one side it is have a screw is present. I hope everybody understood this. I just give an insight to you about the screw on connector, how it is present. Okay, and the second one is bayonet. So, the bayonet connection I will explain to you. In the CRO probe, I hope you remember about the CRO probe in our laboratory. In a CRO probe, we are having one side we have the red color and black color clips are there to hold it and find out the voltages or currents or whatever it may be the waveforms, and you need to calculate the calculations in cathode ray oscilloscope CRO. That probe is going to be placed to the CRO. If you see that connection, you press it and you lock it. Remember na, the probe. You can press it and lock it. If you want to remove it, means you press it, you rotate the opposite direction and remove it. It's a temporary connection bhaiya. Probe is not a permanent connection, permanently connected to your CRO all the time. It's a temporary connection. You press it, you want to remove it, means you remove it also. Okay, and that such type of connection is called as bayonet connection we are having. Which is called as bayonet connection is formed. So once we talk about this bayonet connection, which is called types of connector we are having, it's called as bayonet. So bayonet connection is obtained. It is the most important thing that every engineer has to know about that name. So generally we use the probe, but we don't know the name of the probe actually. So some students obviously knows that also, bayonet connection probe also, or bayonet connector, bayonet mount probe. Actually we call the name like this, bayonet mount probe it is called as. Okay, so no issues. I hope you understand. It also performs a temporary connection bhaiya. Next one is push-pull configuration. Push-pull configuration is very simple to understand. Actually I have the marker pen along with me to show that. So this is the fiber. Assume that for some amount of time भैया ये क्या है, ये हमारा ब्लैक कलर का कैप है ना, ये कैप है, ये लाइट सोर्स है, ये वाला फाइबर है, ये फाइबर है. Now see here, light source and fiber both are going to be make it to like close to each other like this. Whenever we are talking about both are making close to each other, I can going to be make a connection between them. So push, by pushing both the two things, the fiber is goes into the light source. And by pulling, your fiber will separate it and light source and fiber will get separated, temporary connection is formed. So this is what we said to be called as push-pull configuration. Practically we mostly use the push-pull configuration only. For practical purposes, we use mostly the push-pull configuration only. Okay, this is types of the connectors we are having. So after that I am going to be explaining you the next one, that is called as the principle of the connector. If you talk about the principle of connector, it is called as principle of connector. In the principle of connector we are having, it is called as expanded beam principle. It is called as expanded beam principle. Expanded beam principle is the principle we are going to be using in optical communication system. In connector we use this one, which is called as expanded beam principle is used. I hope everybody in the class understood this, which we are using is called as expanded beam principle bhaiya. So after writing this one, expanded beam principle, so what I am trying to doing here is, I am explaining you about the next one, that is called as expanded beam principle mechanism explaining to you. So this is your transmission fiber. I hope everybody in the class understood this. And this is called as the lenses. These are called as spherical lenses we are having. These lenses are called as spherical lens. What the spherical lens will do? Spherical lens will convert your light rays into a parallel beams. They convert into parallel beams bhaiya. I will explain to you neatly with a diagram. See here, I am considering that we are having a light signal coming from this fiber. This fiber is called as which fiber bhaiya? This fiber is called as transmission fiber we are having. So light signal is coming from the transmission fiber and falls on the spherical lens, and that spherical lens was going to be present like this, which is shown in the figure. It is make parallel beams. The spherical lenses are used to convert your light rays into a parallel beams or parallel rays. Clear Nana? That point you must remember clearly. This operation is called as colliminate operation. It is called as colliminate operation. So colliminate we are having, or colliminating, whatever it may be, colliminate or colliminating. Because in antennas we study about the colliminating, that's why I am talking about that colliminating word here. So instead of colliminate, use colliminating Nana. We study in the antennas also, it is called colliminating. Okay, so what is called as the spherical lenses? Spherical lenses are the lenses which are going to be converting your light rays into parallel beams. Okay, converting light rays into the parallel beams we are having. Next, after writing this part, you are once again using the lenses here. So देखो भैया, हम भी lenses use किया इधर. So this is called as the lenses. So we use the lenses here. So whenever we are talking about the lenses, you can write in this way. So the lenses are going to present here, and that will going to be make the light to pass on one particular point, that is focus on one particular point, and that particular point focusing what we are having is called as the receiving fiber. This is called as the receiving fiber we are having. So this is what completely we study in our classroom. Receiving fiber is present. So everybody in the class understood this. What about this lenses is doing? This lenses is doing called as focusing. It is focusing Bhaiya. It is called as the focusing we are having. So culminating and focusing operation. See, this is beam is expanding your beam and then it is focusing here on this fiber. See, transmission fiber and receiving fiber. So expand beam, expanded the beam, the principle is called expanded beam principle we are having. So ठीक है ना भैया, मालूम हो गया ना. नाउ देखो अभी तो 2 पॉइंट बाकी है. सो 2 पॉइंट के बाद हमने थ्योरी बता देंगे इसके लिए. सो प्लीज सी हियर, आई विल एक्सप्लेन द 2 पॉइंट्स टू यू. डियर स्टूडेंट्स, प्लीज फोकस ना. Spherical lenses perform 2 operations, culminating at transmitting side and focusing at the receiving side. If you see about the point, the spherical lenses will always going to be making your beams to be parallelly, making the beams to be parallel, and that parallel beams are come into and placed on the receiving fiber we are having, and focusing on the receiving fiber we have. By using the expanded beam principle, I am talking about the another point, second point. By using the expanded beam principle, the impact of misalignment losses is not present. The reason is, see, even though you have a gap between the fiber, no problem, your beam is expanded and focused. Even the angle is different also, no problem, beam is expanded and then focused. Lateral element, they are not on the same axis also, no problem, your beam is expanded and focused on that one. That is why we are going to using to avoid the misalignment losses, coupling losses of misalignment in the optical components, we use the principle called as expanded beam principle. By using expanded beam principle, what happens is, it is very clear such that your expanded beam principle avoids all the misalignment losses. Okay, and it is suitable for us for using in the SMSA fiber also, using in SMSA fiber also. Okay, that is the second point, right? The second point, little bit extension is also there, that is any connector which was using this principle, expanded beam principle, any connector which is using expanded beam principle is called as expanded beam connector. They are called as expanded beam connector. So most of the times all the connectors are going to be using this principle only. So that is why they are going to be calling it as expanded beam connectors we are having. Okay, they are called expanded beam connectors. Your screw-on connector, if you is using expanded beam principle, your screw-on connector is also called as expanded beam connector. So that is why the connector that is uses in optical communication system is expanded beam connector. I hope everybody in the class understood this. Clear bhaiya, right? Dekho, here dekho. So this is about our connector. I explained about the first component. Connector avoids the misalignment losses, but not mismatch bhaiya. No, mismatch cannot be avoided by the connector. Connector avoids the misalignment losses. I hope everybody in the class understood na? Right? If you understood, if it is clear for you, means put a clear or one thumbs up so that I can go for the next concept. I need to tell some points here. Bhaiya, completion of this I will explain some points as a note to you. So please make a note, all of you. Sagar asked to explain the bayonet once more. Bhaiya, bayonet mount is nothing but it's your probe, CRO probe. See, one end of the CRO probe, you put your CRO probe into the pin of CRO and lock it, and that locking and putting is placing and locking is called as bayonet mount. It is called bayonet mount we are having. Okay, on the bay you are placing and mounting it on that one. Okay, so this is what said to be called as bayonet mount we are having. So I hope everybody in the class understand all the things. So please भैया, next one I will explain to you. थोड़ा होने के बाद हमको एक मैसेज डाले, Thank you, Komal, for the message. You are seeing it's not like that. When the connector, overall connector inside that is having the lenses. Connector is having some size, that size is going to having the lenses. Write down the first point. Thank you for the message, Keshav, Somya. Write down. Note, first point. I think everyone complete copying. Right. Write down the note. Write down the note. A connector is a mechanical interface. A connector is a mechanical interface. Is a mechanical interface. Is a mechanical interface which provides temporary connection between which provides temporary connection between light source to fiber, temporary connection between light source to fiber, comma, light source to fiber, comma, fiber to fiber, fiber to fiber, fiber to fiber, and fiber to photodetector, and fiber to photodetector, and fiber to photodetector, and fiber to photodetector. Next point. The function is to couple light. The function is to couple the light. The function is to couple the light emitted by the light source couple light emitted by the light source, emitted by the light source into the optical fiber cable, emitted by the light source into the optical fiber cable, into the optical fiber cable, into the optical fiber cable. Okay, right. Please put the heading as expanded beam connector. First point. Remaining points I am not telling. Types of connectors, everything is on the board. Please write down the point at expanded beam connector. Nana. First point. Put the heading as expanded beam connector. It employs lenses on the ends of the fiber. It employs EMPLOYS. It employs lenses on the ends of the fiber, on the ends of the fiber, on the ends of the fiber, full stop. Next point. These lenses either culminate, the light emerging from the transmission fiber. These lenses either culminate the light emerging 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 from the transmission fiber, and focus the expanded beam onto the core of the receiver fiber, onto the core of the receiving fiber, onto the core of the receiving fiber. Core of the receiving fiber. Okay. Expanded beam onto the core of the receiving fiber. Right. Next point. Next point. The advantage of this connector is, it less depends on this connector is, it less depends on misalignments, in bracket lateral misalignment, less depends on lateral misalignment. Depends on lateral misalignment. Depends on lateral misalignment. Okay, right. These connectors are widely used in, next point, these connectors are widely used in, single mode fibers, because of its alignment. Single mode fibers because of its alignment. single mode fibers because of its alignment, because of its alignment. Because of its alignment. Okay. So, this is about your connector. I hope everybody has copied it. Okay. So, everybody copied. Okay, bhaiya. Now, I will start with the next component. It is called splice. It is called as splice. Right. Splice provides the permanent connection, between two fibers, provides a permanent connection between two fibers, Next, second point, splicing is of two types. First one is called as fusion splicing. Second one is called as mechanical splicing. There are two types of splicing techniques are there. First one is called as fusion splicing. Second one is called as mechanical splicing. So, I will explain first of all about the fusion splicing. Your fusion splicing is an indoor technique. We use glass electrodes third important thing is it can be used before installation. It will be used before installation. Fourth important point is we can get a point said to be called as lab testing is possible for checking whether amount of loss is high or less. I will explain that point to you. First of all, see the setup, Nana. All of you see the setup. This is a block which is called as fixed block. On the fixed block, we are going to be having a clampers. This is a fiber said to be called as your transmission fiber. When you put a transmission fiber and tight this, see these two are tightening, these two are tightening. Whenever you are getting tight these two values, then definitely what happened is fiber is fixed, it is not moving. The fiber is not moving on the block. This block is called as fixed block. It is not possible to move. This block is fixed and the transmission fiber is also placing on the block and tightening the screws, it is also fixed. Clear na? So, I hope everybody in the class understood this. Next one, Bhaiya, if you talk about the next one, we are discussing about the another block which is said to be called as the movable block as shown in the figure. Please see here. This block is movable and you are going to be placing the fiber on this one which is called as receiving fiber, and this is also said to be called as you have the screws to tighten your fiber. So you place your receiving fiber on the block, and it is a movable block which is movable on the both the two directions. That block is moving close to the transmitter. See bhaiya, moving close to the fixed block, moving close to the fixed block. It is movable, but it is not movable, it is fixed. So we are having the fixed one, so we are not possible to move. So what we are trying to doing is, we are going to be making sure such that your movable block is making close to the, which one? Close to the your fixed block. After making it very close to the fixed block, it comes very close to each other bhaiya. So here we are going to be having a glass electrodes of same refractive index of the fiber. Here also you put a glass electrodes. ये क्या है? Glass electrodes है. This is the glass electrode. I am writing here. The name is glass electrode. It is glass electrode. What we understand very clearly is, this glass electrodes, by sending the fusing it, it is going to be melted, and a connection is going to be formed between these two, which is as shown in the figure. This is called as your splicing, the splicing technique called as fusion splicing we are having. So how this glass is melting? By fusing the glass electrodes, the glass is melted and the connection is formed. After connection is formed, we remove this glass electrode supply, fusing supply, we remove this clamp, we loosen this. What to tighten clamp is loosen this. We perform the losing of this clamp. See here, loose this one, the fiber become free. Same here also, the fiber become free, losing. Now the fiber is coming like this, which have a connection. See, the fiber come outside, which have a connection between the transmitting and receiving fiber. Now what is this lab testing is, I will explain very clearly to you. I will send some power to this one, and I will get some output power. From my input power and from my output power, I came to know how much loss is present. And by removing the amount of loss from the fiber loss, then whatever the loss present here is the splice loss only. So we know such that amount of loss offered by the splice is present here. So that's why lab testing has to be done. After doing the splicing, the loss is very, very high. You once again remove that and once again done the entire process of splicing very carefully. This is the one of the advantage of fusion splicing. But what is the disadvantage is, this type of splicing can be performed only before the installation. After installation it is not possible. So to overcome that problem after installation, problem of installing this, we are going to the another one that is said to be called as mechanical splicing. भैया mechanical splicing के लिए just check this one, it is called as outdoor splicing technique. Complete opposite ना ये indoor technique है, on the other hand it is outdoor technique है. So fusion splicing indoor, mechanical splicing outdoor. Now see here, second one is fusion splicing use glass electrodes, but mechanical splicing uses optical cement or gel. Using optical cement or gel is used. Optical cement or gel is used. That is called as second one. Now coming to the third one, it is before installation bhaiya, opposite. It is after installation. After installation, what happens is generally sometimes due to the development in the process of infrastructure, we are going to be digging the road or digging the side of the building or making an extension of the roads or water pipelines or sewage pipeline, what it may be guys, infrastructure, everything is infrastructure right now. So that infrastructure what we are developing in the process, we are having digging the ground, so cable is cut down. For the cut down cable we cannot remove the entire cable from the earth and take to the lab and make it splicing and come back bhaiya. It's not possible all the time. Once you dig it means it has to present in the earth for 100 years. Don't think that for every small issues you are making the complete fiber remove from the earth and taking to the lab and coming back once again placing it. Finish. Kel khatam. Very costly it is. Okay. So that's why what you are trying to doing here is, it is having the fixed block we are having. So after installation any problems are occurred, we are going to be using the mechanical splicing. This fixed block movable blocks we are having, this technique was used only before the installation bhaiya. So that's why the advantage for that one is lab testing is there, but here there is no lab testing bhaiya, we can't test anything. Splicing will be done carefully. While doing splicing, careful, be careful, cautious and be careful. So here there is no lab testing bhaiya, there is no lab testing is present. So I hope everybody in the class understood this. So I explained the 4 points, please concentrate. The difference you find out here is, other than the opposite version, glass electrodes ka difference is optical cement or gel. Optical cement or gel. Cement is nothing but a powder is available, mixing some water or some what is called as the gum, the elastic nature of gum is there, that is also mixed, we get it. Gel is one which is available in the market directly bhaiya. By placing a small gel, when the air is coming within 5 to 6 seconds, it will get tightened, no problem. So that's what the gel we are having. Now I can explain the types of mechanical splicing, Nana. So fifth point, that is types of mechanical splicing. All of you please concentrate. Types of mechanical splicing, dear students. The first one is called as V-groove. It is called as V-groove. See the diagram I am drawing here. This is called as the V-groove we are having, like a V shape. See, like a V shape. If I take a book here, that looks like a V shape like this. See, V shape like this, and I put the fibers here. Now on the base of the V-groove, we are having the fibers, placing a fiber, and from the top on the side we are putting some optical gel. From the top we put some optical gel. When you put some optical gel from the top, after some time what happen means the fibers will connected, and we remove this V-groove. See, by removing this V-groove, fiber is connected bhaiya. So here the V-groove is acting as a base, okay, to place your optical cement or gel perfectly on the axis. Okay, see here, dekho bhaiya, dekho. To understand this, I am explaining here with a diagram. Dear students, concentrate. Writing here is transmission fiber. आ गया, आइडिया आ गया, हाँ, वेरी गुड. ट्रांसमिशन फाइबर. देखो भैया, ये क्या है, रिसीविंग फाइबर, दोनों एक ही साथ है. नो बेस इज दिस इज द बेस लाइन. Okay, actually straight line, not much that much good artistic one, that's why I got some other line has formed. Of course straight line bhaiya. Put a optical cement gel from the top. See, they both touch to each other. Some optical cement you will put from the top. Cement daliya bhaiya, daliya. Cement means you are not constructing any building bhaiya. Thoda cement hai, thoda cement daliya idhar. Okay, थोड़ा सीमेंट डालने तेरे कनेक्शन हो जाएंगे. कनेक्शन हो जाने के बाद क्या करेंगे, ए वी-ग्रोव को निकाल दो, वी-ग्रोव से निकाल दो. ये वी-ग्रोव रिमूव करने के लिए क्या आ जाएंगे, दोनों फाइबर, ट्रांसमिशन फाइबर, रिसीविंग फाइबर के लिए हमको कनेक्शन फॉर्म हो जाएंगे. ओके, एंड दैट इज व्हाट द इंपॉर्टेंट थिंग दैट यू कैन फाइंड आउट बाय द वी-ग्रोव टेक्निक. सो एवरीबडी इन द क्लास अंडरस्टूड दिस. ओके, सो दिस इज कॉल्ड एज द वी-ग्रोव टेक्निक वी आर हैविंग. After the V-groove, next we are moving to the another one, that is called as second one, which is called as 3-tube method. The 3-tube method is one of the worst method we are having, guys. I will explain the procedure, please concentrate. 3 tubes are connected like this, which are as shown in the figure. 3 tubes are connected like this, which are as shown in the figure we are having. Please concentrate. First of all, guys, when the 3 tubes are connected to each other, you are going to forming some hole present here. Dip the transmission fiber and the receiving fiber in the optical gel, send through it. Okay, dip it, send through it. By the God's grace, if they both connected to each other in the first trial, then very happy. If it is not connected, remove the tubes, check it. If not, again dip the cement, send it. Trial and error method. Dip it, send it, dip it, send it. When it hits, बस सुपर भैया, सुपर हिटेड हो गया, कनेक्शन फॉर्म हो गया. That's why it's one of the worst technique we are having. Next important one is called as the third one, that is called as ferrule भैया. So third one is called as the ferrule. थोड़ा ध्यान से सुनो. It is called as ferrule. So attention pay करो भैया. The ferrule diagram I am drawing. So this is the diagram of ferrule we are having. So everybody in the class understood this. This is a ferrule diagram we are having. So once we talk about the ferrule, we can tell in this way. Which is called as the ferrule we are having. It's called as ferrule. So this is the setup of ferrule we are having. Hope you understand, na? See, small hole is present here, small hole is present here. From top also small hole is present here, bhaiya. Now we are sending the fiber. See, I am changing the color to understand that. I am changing the color. So भैया देखो भैया, हमको fiber send किया अंदर से. Right now, see, stopped here. By seeing top of that, you have find here, fiber is shown here. Receiving fiber. See, receiving fiber is also going to be connected here. Am I clear na? Transmission fiber, receiving fiber, both are connected to each other. So ऊपर से हमको जेल डालेंगे. So ऊपर से जेल डालने के लिए क्या हो जाएंगे? वो जेल है. So this is the blue color gel we are having भैया. जेल डालेंगे तो हो जाएंगे as connection formed. Now just observe it. By passing that the gel, the connection is formed, and that connection what we are going to be having will make between the transmission fiber and the receiving fiber. Our connection was effectively done. So we are very much happy for this one, which is called as ferrule is present. Okay, so see here, connection is formed ho gaya. It is called as the ferrule mechanical splicing. What is the problem here? Removable, removable, non-removable. If you want to remove it, once again you have to cut the fiber here and here, then no splicing. Because ferrule is not it is not a removable, it's non-removable. It's a non-removable means excess loss will get. That is called as 0.1 dB. 0.1 dB excess loss we will have. 0.1 dB excess loss we will have. I can write one point here, just try to understand. If you talk about your connector, connector loss is always present from 0.5 to 1.5 dB we are having. This much amount of loss is offered by the connector. Next one is called as splice loss. Splice loss is nothing but it is present from 0.1 to 0.5 dB. Maximum loss of 0.5 dB is present with the splice, which is called as splice loss we are having. So we tell about the two things bhaiya. One is called as the connector loss, another one is called as the splice loss. Connector loss is nothing but it is called as your 0.5 to 1.5 dB we are having. Okay. So next one is called as your splice loss is 0.1 to 0.5 dB. If you use a ferrule, see, if you use a ferrule, then what happens is very clear such that excess loss of 0.1 dB is getting 0.1 dB excess loss. That means if you will splice, general splice is having 0.5 dB. If you use splicing by using ferrule, 0.5 changes to 0.6 nana. So plus 0.1 is added. I hope everybody in the class understood this concept. So for 0.5 dB excess loss, 0.1 will be added. Clear to everybody in the class, Nana? This is nothing but your splicing techniques we are having. A student small doubt placed in the chat box. Sir, whether the fiber will go into this tube or not? See, assume that we are having three tubes bhaiya, like this. See, एक tube है, दोनों tube है, तीन tube है. ओके, इसी पास इसी साइड की इसी साइड के अंदर से चल जाएंगे, बट देखने के लिए ऊपर से नहीं, कुछ ही नहीं है. अंदर जाने के लिए जाएंगे और नहीं जाएंगे भी कनेक्टेड होने चाहिए ना. दोनों फाइबर्स विल बी डेफिनेटली हैज टू बी टच विथ ईच अदर एंड कनेक्शन हैज टू बी फॉर्म्ड. इन फेर्रूल ऊपर से दिखेंगे, इन फेर्रूल ऊपर से दिखेंगे, थोड़ा होल है. इन वी ग्रो होल कुछ भी नहीं है, ऊपर ओपन है ना, ऊपर से देखेंगे. ये ट्यूब मेथड में किधर से देखेंगे? फ्रंट है और बैक साइड भी सेंड करेंगे. सो फ्रंट भी सेंड करेंगे, बैक भी सेंड करेंगे. अंदर जाएंगे और नहीं जाएंगे और टच हो जाएंगे, हमको नहीं मालूम है. इसी के लिए बहुत दिक्कत हो जाएंगे. टू ट्यूब मेथड वी डोंट यूज दैट इन द योर मैकेनिकल स्प्लाइसिंग, बट one of the technique for trial and error method, Okay, trial and error method we are going to be using that, which is called as a 3-tube method we are having. So this is completely, this concept is completely about your connector and splice I explained to you. Bhaiya, there is no points to write for the splice. I explained everything to you here in the board itself only. It's about the point also, all the points. So it provides permanent connection. So I hope you understood this. Okay, put a thumbs up if you understood, or clear message also, no problem. I can go for the next concept. Any doubts, please ask it here. We go for the next one. Completing also, put a message, Nana, because I couldn't understand whether you completed or not. Soumya, we need to take such that profile mismatch cannot be present. The reason is we will check the fibers before making them splicing. Okay, mismatch loss is nothing but an areas will be match, numerical apertures will be match, and the profiles will be match. Then only we will take. We cannot make two profiles, two different profile fibers will be connected. Okay, we have to check it before splicing. We have to check it. After the splicing, we check it, means there is no use, Nana. So we have measurements to check your profile, we have measurements to check your numerical aperture, we have measurements to check our area also of the fiber. That's called optical measurements we are having. थ्री ट्यूब स्प्लाइसिंग में क्या करेंगे मीन्स वी जस्ट dip the transmission fiber and receiving fiber in optical gel and pass through the center of this tube from one end, from front of this tube from one end, and back of also we can send it and both will get touch to each other within the three tubes. Then connection will be formed by using the splicing called as mechanical splicing, but it's a trial and error. If the connection is not formed perfectly, again we remove it and we can do it. We just rub that optical gel once again, you remove the fiber and once again do the splicing. But nowadays mechanical splicing is not using BIA. The reason is we can get the fusion splicing with very portable machines also, which can carry from one point to another point. Portable machines also available. Previously we have a big size, OVM vans are there, but right now they become small size, box will coming. You can carry it and you can put it, because advancements in optical has done very drastically in a short span of 1 decade. In a decade, so much amount of advancements are came into the picture. Earlier we need to have any connection is lost means it takes so much amount of time to find out where the connection is lost, checking the hub points. But right now it's very easy to check it bhaiya. Between the two hub points, they are going to be maintaining some random picks by taking the, some of the times you also see that some people are having some wheel in the hand, round wheel, and some meter is present on the top of the wheel, and they are moving, walking on the roadside and checking at the, on that signal strength, how much signal is present, optical fiber cable is getting signal or not, like that. It's testing purpose, that is. There are so many number of advancements came into the picture bhaiya. In that process, mechanical splicing is removed off and completely fusion splicing is used. So, can you please tell me which type of splicing is very important for us? The type of splicing very important for us is fusion splicing. Yes or no? So, fusion splicing or not? So, this is completely about the splice. So, some of the students has placed a message to me such that it is completed. So, I am going for the next topic, that is nothing but an. Soumya also asked one doubt. Splicing junction cannot mismatch occur. At the splicing junction, mismatch means misalignment has to be present, mismatch will also be present. If mismatch means areas are not changing, or because two coupling losses will be present at fusion splicing also, it must be take care by ourselves such that there must not be having no gap misalignment, no lateral misalignment, no angular misalignment. Whenever you are placing here, make sure such that they lie on the same axis, no gap is present, perfectly done or not. That is why you are doing lab testing bhaiya. By doing the lab testing, we understand. If you have a written loss, you know clearly, okay, loss is very high, so the splicing is not a good splicing, remove this, and once again be careful and be cautious, and then you can do the splicing. The technician was going to be trained for that one. So, as an engineer, we are always going to be in a top notch level such that we study the concept, but we do not want to talk about that one. Technicians, the ITA technicians and diploma students will do that. As an engineer, we always know the concepts bhaiya. So, that is why we know about completely about the splicing. So, I hope all will get a clarity regarding this. So, 3-tube method means, see, from front I will send one fiber, dip in the gel. The tube on the back side also present, on the back side also we have the same connection like this, na, hole is there, na, see 3 tubes, see tube 1, tube 2, tube 3, tube 3 is connected. So, back side also I have the same thing, na. So, same thing I can send from back side also, trial and error method. When they are connected in one shot, super nana. If they are not connected in one shot, you will try for the remaining times, n number of times to get connected to each other. So, this is what said to be called as your mechanical splicing. So, out of these two, which one is the best splicing technique used in optical communication bhaiya? Fusion splicing. Yeah. Thank you. Thank you for messages to each and everyone. So, the only way I can interact to you is the chat box, Nana. There is no other alternate for me. So, all the doubts are cleared. I explained the doubts to Soumya and so doubts to Bhakti Patel also. So, now I can start with another concept that is called as coupler. Okay. तो ध्यान से सुनो भैया, कपलर इंपॉर्टेंट कॉन्सेप्ट है. Coupler. Okay. So, when we see about the coupler, so talking about the coupler, coupler is a device which is an passive device we are having. The coupler is a passive device we have, and that passive device is used to send the distributes the light from a main fiber into one or more branch fibers we are having. Okay. So, this is called as coupler. Your coupler is also called as fiber optic coupler bhaiya. It is also called as fiber optic coupler. 2 minutes concentrate, first 2 minutes or approximately some 5 minutes of time. First 5 minutes is very important bhaiya. So, just listen, fiber optic coupler. Okay. See, what are the components I am explaining? Components I am explaining to you, we study in the first class elements of optical communication. I hope you remember that. The day one, please refer your notes. First one, first class introduction topic, day one. I explained that first we have a connector, we have a splice, we have coupler, we have repeater, and at that time I told to you in the class also, we study all these things in detail when we go into the concepts. Okay, there I can just give the definition, but here we are studying in depth now. So fiber optic coupler. What's a fiber optic coupler? The first point is, don't worry about the points, I can definitely explain those points in your notes neatly. Okay, bhaiya, we are having a coupler is a passive device, and second important one is, so bhaiya, whenever we are discussing about the coupler distributes the power, distributes the light from main fiber to okay, branch fibers, from main fiber to one or many branch fibers. Okay, from main fiber to one or many branch fibers. Okay, bhaiya, this is the coupler. So whenever we see about the coupler operations is of two types we are having. Okay, those I can explain to you. So we have a coupler, the two types of operations are there. The first one is, okay, one to many coupler, bhaiya. The second one is many to one coupler. First one is called as one to many couplers, second one is called as many to one coupler. So we see about the, here it is called as a coupler we have. The input what we are giving to the coupler is nothing but an said to be called as input. These all are said to be called as the outputs we are having, which is called one to many. From main branch, it is main branch. Okay, from main fiber. These are all are the fiber branches or branch fibers. The power that is coming from the main fiber is going to be splitting into the branch fibers, that is what said to be called as your output we are having. It's called as your coupler. Such type of coupler is called as splitter. That is called as splitter. The function of that coupler is called as a splitter. Next one is called as many to one. If you talk about the many to one coupler, completely opposite, nana. It's a coupler. We have many inputs are there. See, all these are inputs, nana. Many inputs are there. From many sources of fibers we are having, we are converting them into only one output. That is called as converting them into only one output we are having. Okay. So what's said to be called as your coupler we are having. This is what said to be called as a combiner. It is called as combiner. From different branches you are getting the optical power. Your coupler is going to be combine that and gives as only one output value, bhaiya, and that is called as combiner. So there are two operations present in a coupler. One is splitting, other one is combining. Okay, bhaiya? Right, very good. Now see here, again bhaiya, listen carefully. Talking about the point 3, said to be called as types of coupler. So, we are talking about the types of couplers. When you talk about the types of coupler, the first type of coupler is called as star coupler. It is called as star coupler we are having. Second one is called as T coupler, bhaiya. It is called as T coupler. Third one is called as fused coupler. Of course, we are also having another one is also in the coupler, that is called as WDM coupler. WDM means wavelength division multiplexing coupler. I explain that coupler to you whenever the WDM concept is completed. At that instant I can explain you the WDM coupler. Why? Because means at this stage we do not have that much knowledge about the WDM concept. So once WDM concept is completed, I myself only explain to you, bhaiya, very neatly about the WDM coupler. Okay, so don't think much about that. I am writing here only 3 couplers only, but as per the couplers, we are having totally 4 types of couplers are there. One is called as star coupler, second one is called as T coupler, and third one is called as fusor coupler we are having. The fusor coupler is one part of extension of the star coupler only, but of course it is specified in the syllabus also very neatly for us. They ask questions also based on that. Okay, so it is about the fusor coupler we are having. If you know the star coupler perfectly, means fusor coupler nothing to you. You can tell very easily. WDM coupler on the other hand, which works with the wavelength division multiplexing, where it is also splitter and combiner, both will be present, and I explain those things when we go into the WDM technique. So if you want to write, means you can write here also WDM coupler, but I can't explain here anything to you. That's why I don't want to make you too confused. While studying, you will get confused. Why sir was not explained WDM coupler? Okay, so there must not be have no what is called misunderstanding between you and me. That's why I'll explain the WDM coupler in the WDM technique. Okay, right. Please coming to the star coupler, Bhaiya. For 2 minutes of time, we need to focus on the star coupler concept. I request all the students to please stop writing and listen this one, Bhaiya. Listen, stop writing. 2 minutes. I just give time for you to copy this once again. It is completed. Okay. So star coupler, if you talk about the star coupler, you can tell one simple thing. Star couplers is of 2 types. 2 types of star couplers are present. The first type of star coupler is called as transmissive. Okay. Transmissive star coupler. The second type of star coupler is called as distributive. It is called as distributive star coupler we are having. It is called as the distributive star coupler we are having. So one is called as transmissive star coupler, another one is called as the distributive star coupler is present. Now I can explain you about the transmissive star coupler. Dekho bhaiya. So it's time for us to know about the transmissive star coupler. So I am drawing the diagram here. Oh. Oops. Okay, so transmissive. When you talk about the transmissive star coupler, I am just drawing the diagram. It is called as a mixing block. Dekho bhaiya, we are having a block called as mixing block is present. It is called as the mixing block. So for this mixing block, we understand very clearly such that inputs are there. N inputs are there. Dekho bhaiya, N inputs are there. So on up to N inputs are present. Now for N inputs, we are going to be having N outputs bhaiya. N outputs are there. Dekho bhaiya, N outputs are present. Having N outputs are present. These are said to be called as the N inputs we are having, which is said to be called as N inputs. These are called as N inputs. We are having N fiber inputs. So here you are giving the input power. The input power you are giving is equal to P in here. And these all are called as the N outputs, Nana. It is called as N outputs we are having. So it is called as N by N coupler. This is called as mixing block. N by N coupler we are having. So everybody in the class understood this. That is what the mixing block we are having. So P in is given in port, one of the port in N inputs. And the P out what you are getting here is called as P out will be appear from one of the output ports. Okay. So we can write like this POT. POT means total output power. P out T means total output power we are having. When you talk about the total output power, it looks like this bhaiya. So P out of T. When talk about the P out of T, we can tell like this, which is said to be called as P out of T. P out of T means total output power. See, for one port you are getting P out, remaining will get. That means how much number of ports are there? N ports into P out. N ports into P out. N into P out is called as the total output power we are having. P out is equal to, the value is P out T, total output power is equal to N into P out. Okay. Now see here bhaiya. Output power P out is equal to, we can also written as the value is equal to P in by N. Written as P in by N. So this is about the transmission fiber we are having. So P out is equal to P in by N. What is N? N is the number of inputs. So output power getting here is nothing but N, which is going to be the combination of the N inputs are there. The P in power only distribute to N inputs we have now. So output power will share. See, for example, I am giving here 1 watt means that 1 watt will distribute to all the N ports or not. So how much share it is? 1 watt divided by N, that is going to be the share we are having. Is to understand clearly, bhaiya, we have only 4 ports are there. So one input power 1 watt is given, then you can get 1 by 4, 1 by 4, 1 by 4, 1 by 4 will be distributed. That's how I am writing. P out is equal to P in by N. How I P in by N? So 4 ports we are having, input are giving as equal to 1 watt I am giving. So each output port will get a power of 1 by 4, 1 by 4, 1 by 4, 1 by 4. So all adding 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 is equal to 1 by A. Okay, yeah. That's how they are writing by A. So P in by N. So I think you got a good clarity regarding this. Now this is completely about the transmission block. I will explain 2 types of losses. So please dhyan se suno, 2 types of losses. The first loss is called as splitting loss. The first loss is called as splitting loss. Okay, splitting loss. Your splitting loss is also called as the power division. Also called as a power distribution ratio also. Power division also called as power distribution ratio also. The problem with the ES is we need to remember all the names bhaiya. We have to remember all the names. That is what are the names we are having for that one, splitting loss, power division, and we are asking about that power distribution ratio also. All are same only, formula is same only, but names are different bhaiya. So power distribution ratio, very good. So students, see the formula, very simple nana. See splitting loss, because of splitting the power we got some loss. I will tell like this, loss will be given as 10 into log of, we study in the classroom, P in upon input upon output. But what is your output nana? P out, see by splitting it, the output power, input power is splitting into output power, we got a loss, P in by P out, that is called splitting loss. The power that present in the input is dividing, that is why power division. The power in the input is distributing between all the ports, that is why it is called power distribution ratio. Clear nana? Okay, very good, right. Now that is equal to P out, see that is 10 into log of base 10 nana. I forgot to write the base 10, students, if I forgot to write the base 10, please make it sure in the notebook, write down with respect to base 10 bhaiya, everything base 10 only. P in, kitna hai bhaiya P in? P in is the input power. What is P out? See P out is P in by N. See bhaiya, P out is P in by N. So I am substituting the value called as P in divided by P in by N. So N will cancel, P in will cancel, N will come upside. Okay, space problem. I will write here formula, that is equal to 10 into log of value is equal to N. And that is called as splitting loss. This was splitting loss. 10 into log 10, 10 into log 10, okay, 10 into log n of base 10. So this is what said to be called as the splitting loss we are having. So please copy this part. I will explain the remaining also. Excess loss is there. I will explain that part also to you, how that excess loss will come. So please copy it. we have n inputs, showing such that general case n into n, okay. So sometimes we are going to be having only one input. See, calculation also depending upon the only one input only. The n inputs of outside we are going to be considering. The n inputs of outside we are considering. In the next star coupler, you understand the same thing, bhaiya. Why means distributive star coupler is going to be having only one is used as input, remaining all used as outputs only. So it is clear such that even though you are having n inputs, we are using only one input to give your power. Okay, right. Keshav, Radhika Devi, Sijal Jain. Again, thank you for the messages. So such that I came to know such copying is completed. I am moving to the another topic of your star coupler, transmissive star coupler. Okay, transmissive star coupler. I will explain the excess loss concept. ठीक है ना भैया? I will explain the excess loss concept. So see here. I am writing here excess loss by a continuation for this one, continuation for the topic of your continuation. Excess loss. Excess loss is given as 10 into log of, see how the loss was given, input by output or not, study in the classroom. Okay, very good, Nana. That is equal to input P in divided by P out capital T, total output power of base 10. Okay, so excess loss is equal to 10 into log of P in by P out of T, which is called as excess loss we are having. The formula for excess loss. Now total loss that present in your fiber, total loss present in your coupler, sorry, star coupler, is called as combination of splitting loss plus simply it is called as your excess loss. So combination of splitting loss plus excess loss is called as the total loss we are having. So what is this? This is called as a splitting loss. So these are the very important formulas that are present in your star coupler. Okay, important in your star coupler. Questions asked in the exam based on this only, bhaiya. Excess loss what you are getting is, it's a combination of total output power upon the input power also we can tell. Because loss can represent either in P in by P out or P out by P in also, bhaiya. So there is no problem regarding that. Okay, right. Next one is, so after writing this one, right, see here, I am talking about the another one that is called as your distributive. See, distributive star coupler. If you talk about the distributive star coupler, so you got a distributive star coupler. Once we see about the distributive star coupler, looks like this. See the disadvantage that what A.R. Singh asked is overcome here. The question. So this is the reflective material. right bhaiya, it's a reflective material we are having. What is this called as? Reflective material. This is one port, port 1, port 2, port 3, so on up to port N. Clear na? Distributive. These are called as N I by O ports, called as N I by O ports. N I by O fibers. I by O stands for input output port fibers. Here we are giving the input power called as Pin. You will get P out here. Remaining ports also you get P out. See, out of N I by O ports, one is using for input, remaining all are using for outputs. In the last diagram, if you observe clearly, here N inputs are there, N outputs are there, but power is fed only to one input via. Okay, remaining all inputs, what happening means they are not used at that instant, may be used for any other application. So that's what the case. Now what your problem present here is over rectified. See that the problem is rectified by taking the I by O ports, so that is equal to P in and it get the P out value. So it is called reflective material is present. Can you please explain what is your P out, Nana? P out is equal to P in upon number of ports is N, out of that one port is using input, remaining all are for outputs. So outputs is N minus 1. This is not the case in your so called transmissive type of star coupler. There what we studied is very clearly such that N input ports, N output ports, P out is P in by N, because it is distributed towards the N output ports. But here your output is available only with N minus 1 ports. Why? Because out of N I by O ports, one port is used for input, none, remaining ports are used for the output. That is why P out is equal to P in by N minus 1. Clear? Good. Very good. This is called as a distributive star coupler. Formulas remains the same. Every formula that we are having remains the same. So once you talk about your P out, what happened to the splitting loss? Come on, tell. Splitting loss, start. Splitting loss. N output ports are there, you got N, but how many number of output ports are there? N minus 1, so that is equal to N minus 1. Because of your distributive star coupler. Distributive star coupler, so N minus 1 is present. Now after that we will see about the next one called as excess loss. Excess loss formula is same only, P out T. Your P out T is equal to N into P out, but here it is equal to N minus 1 into P out. Okay. What is P out T? Total P out is N minus 1 into P out. That is called distributive star coupler we are having. So this is completely about the star coupler. I will give one diagram for a star coupler diagram. This is star coupler, which is called as star coupler. And here we are having T by R. Here also we are having T by R. So here also we are having T by R. What's the meaning of T by R? Means trans receiver. The meaning of trans receiver is it have a capability or ability to transmit as well as receive at the same time. So if you have a trans receiver, best example is your mobile phone. You can transmit, you can receive also at the simultaneously same time, which is called as trans receiver. So for that trans receiver, we are having two cables are running. One is incoming, other one is outgoing. One is incoming, that is duplex, other one is outgoing. Here also same thing, one is incoming and one is outgoing. And here it is connected to the other networks. So connected to other networks we are having. Connected to other networks. So this is completely an explanation regarding the star coupler, how they are connected. It uses a duplex type of transmission. What's the meaning of the duplex type of transmission? It is performing the both exchanging the data. So exchanging the data. So what is said to be called as duplexing we are having. Okay. So duplexing we are having. So just see here, the transmit as well as receives two-way communication. Two-way communication is called as exchange of data. We are having exchange of information. But we have two types of information has to be transmitted. One is called exchange, other one is called as transfer. Transfer means only one way. I am just transfer the information to you means I will send the information to you. I am not expecting any information from you. Exchange means both will interact with each other, in sync with each other, in synchronization with each other. Clear na? So that is what said to be called as your star coupler has to perform network diagram. So this is about the star coupler. I will take the T coupler to you. Please copy it. Please copy this one. AR Singh splitting loss is completely telling you about the, okay. So splitting loss is completely telling about the how your power is splitting in between the N ports. How your power is splitting between the N ports, that is called as splitting loss. But if you talk about the same thing with respect to your excess loss, how that power is going to be moved from coupler input to output, how much excess that loss was going to be obtained because of all the output ports. Each and every port will go into their ports means they are fibers, nana. The fibers will provide some loss and that loss is called excess loss. How it is splitting out of all N fibers is called as splitting loss. How it is going to be moving from one point to another point, accessing is called as excess loss. Take a small break. So take a small break, 20 minutes break, we will see after the break. Okay. So take a small break, bhaiya, 20 minutes break. So for copying also requires some time and we will see after the break. Okay.